In this lesson, we will develop a method for evaluating the limits of functions which cannot be done by direct substitution. Well, you know how to evaluate limits of functions. For example, if you want to find the limit x approaches, say 2, of x squared divided by 2x plus 1, what all you need to do is replace your x by 2 and find the value of that. But how about this? If I want to find limit x approaches 0 sine x divided by x. Now, how do you find the limiting value of this? If you set x equal to 0, sine of 0 is 0, so this will be 0 over 0. Now, that is a form that you cannot really calculate. Now, when it comes to situations like this, we need to have a different approach. So in this lesson, we will see how to evaluate limits like this, which cannot be done by direct substitution. Well, you know that limits of quantities like this can be actually done graphically. If you draw the graph of sine x divided by x, what kind of graph would you get? In the neighborhood of x equal to 0, the graph sort of looks like this, where this is 1. In other words, this limit is actually 1. Although, when you replace x by 0, this yields 0 over 0, the value of this limit is actually 1. Does that mean that 0 divided by 0 is 1? No, certainly not. 0 divided by 0 is a form that you cannot determine. Alright, so let's develop a method for doing these kind of limits. So, in this lesson, we investigate limits of the form limit x approaches c f of x over g of x. This is the form that we will investigate. Now, as I just showed you, limit x approaches 0 sine x over x is of the form 0 over 0. So when x equal to c, if f of x divided by g of x is 0 divided by 0 or infinity divided by infinity, then such a limit is said to be an intermediate form. It is of intermediate form. Now, intermediate form means the evaluation of this limit is not complete by doing this. You got to use another approach. Now, if limits are limits of this type means limit x approaches c f of x divided by g of x. If such limits yields 0 over 0 or infinity over infinity, when you do the direct substitution, then these limits are said to be of the intermediate form, and we have a rule that can be used to do that. L'Hopital developed a rule for doing these kind of limits, and it is called L'Hopital's rule. So the rule says, if the limit of f of x divided by g of x as x approaches c produces an intermediate form 0 over 0 or infinity by infinity, then limit x approaches c f of x divided by g of x is the same as limit x approaches c f prime x over g prime x. Now, in other words, the limit of f of x divided by g of x as x approaches c will remain the same as limit x approaches c, the derivative of f of x divided by the derivative of g of x. Now, for example, can you do this in your mind? We have, in the beginning I told you, x approaches 0 sine x divided by x. Now let me write that down for you. Limit x approaches 0, all right, limit x approaches 0 sine x over x. Now, by direct substitution, this will give you 0 over 0. Now, according to L'Hopital's rule, this is the same as limit x approaches 0, the derivative of sine x, which is cos x, divided by the derivative of x, that will be 1. Okay, now look at the difference in here. So according to L'Hopital's rule, limit x approaches c, f of x over g of x is the same as limit x approaches c, f prime of x over g prime of x. So the example I gave you, limit x approaches 0 sine x over x. If you replace x by 0, you get 0 over 0. So it is of the intermediate form. If so, the rule says this will be the same as limit x approaches 0 of the derivative of sine x, which is cos x, divided by the derivative of x, which is 1. And now, replace your x by 0. What is cos of 0? Cos of 0 is 1. And 1 divided by 1 is 1. The value of that limit is 1. And you can prove that graphically. Alright. Okay, let's look at a couple more examples. Let's try this limit. Evaluate the limit. Limit x approaches 0. E to the power of 5x minus 1 all over 5x. Alright, let's try replacing x by 0. When x equals 0, this will be e to the power of 0 minus 1 divided by 0. What is e to the power of 0? E to the power of 0 is 1. Anything raised to the power of 0 is 1. So that will be e to the power of 0 minus 1 is 1 minus 1, which is 0. So this is of the form 0 over 0. When x equal to 0, we have e to the power of 5x minus 1 over 5x. That is 0 over 0. This is the intermediate form, which means we can apply L'Hopital's rule right. So since this is the intermediate form, we can apply L'Hopital's rule. What's the rule? We have limit x approaches c, f of x divided by g of x is the same as limit x approaches c of f prime x divided by g prime x. So this limit is the same as limit x approaches 0, the derivative of the numerator divided by the derivative of the denominator. That's right. Now tell me, what is the derivative of the numerator? The derivative of e to the power of 5x is 5 e to the power of 5x. Is that right? And the derivative of 5x is 5. So that will be limit x approaches 0, 5 e to the power of 5x divided by 5. Well, how about now? Can we replace our x by 0? And what do you get? Well, that will be limit x approaches 0, e to the power of 5x, because 5 and 5 will cancel. And what is limit x approaches 0, e to the power of 5x? Replace your x by 0. It gives you e to the power of 5 times 0, that is 1. So the value of this limit is actually 1. Try this on a calculator, see how the graph looked like. Well, put it on the calculator, y1 equal to, and draw the graph, and you can see as x approaches 0 from the left and x approaches 0 from the right, the value of that limit is 1. That's right. And if you watch carefully, actually there's a hole in the graph there, but the limit is actually 1. There's a hole there because the function is not defined for x equal to 0. Is this function defined for x equal to 0? No. So there will be a hole in the function graph at x equal to 0. But the limit from the left is equal to the limit from the right, equal to 1. All right, let's do another one. Evaluate the limit x approaches negative 1 of 2x squared minus x minus 3 divided by x plus 1. All right, try doing this. Replace your x by negative 1. And the numerator become negative 1 squared is positive 1. 2 times 1 is 2. And minus negative 1 will be positive 1. 2 plus 1 is 3. 3 minus 3 is 0. So the numerator becomes 0. And x replaced as negative 1, the denominator also is 0. So the numerator and the denominator both are 0. Therefore, this is of the intermediate form. Remember, you can use L'Hopital's rule only if the limit yields the intermediate form. Since this is the intermediate form, we can now use the L'Hopital's rule. What is that rule? Limit x approaches c, f of x divided by g of x is the same as limit x approaches c, f prime of x divided by g prime of x. So that will be limit x approaches negative 1, derivative of the numerator divided by derivative of the denominator. And what is the derivative of the numerator? That will be 4x minus 1, and the derivative of the denominator is 1. So that is limit x approaches negative 1, 4x minus 1 divided by 1. Can you replace now x by negative 1? Well, that's right. So that will be 4 times negative 1 minus 1 divided by 1. And that is negative 5. Now, can you draw a graph of this 2x squared minus x minus 3 over x plus 1 and see if the limit is actually negative 5? Well, this is the graph of this. Try that on your own. You can see this is actually a removable discontinuity here. You can factor the numerator and cancel that x plus 1. But you can see when you graph this, the graph will have a hole at x equal to negative 1. Watch this. This is x equal to negative 1. I don't know whether you can actually see that's the x equal to negative 1 and you have a hole there. But limit x approaches negative 1 from the left as well as from the right. That limiting value is negative 5, negative 1, negative 2, negative 3, negative 4, negative 5. That's the limiting value there. Alright. And I've shown you that hole in there. Let's try another one. Evaluate the limits. Limit x approaches infinity.